There is a profound stillness that settles over the world in the quiet hours of the night. If you are sitting in a comfortable chair or lying in bed waiting for sleep to come, your senses tell you that you are completely stationary. The floor beneath you feels solid and unmoving. The walls of the room are fixed in place. The air is calm. If you look out the window at a distant tree or a street lamp, they stand like sentries, anchored deep into the ground. Every instinct we possess, every signal from our inner ear, confirms a simple, undeniable fact. We are at rest. But this feeling is the greatest illusion in nature. It is a deception so convincing that for thousands of years, humanity believed the earth was the unmoving center of everything, a heavy, fixed stage around which the sun, the moon, and the stars performed their nightly dance. It takes a leap of the imagination to break this spell. We must close our eyes to the stillness of the room and open our minds to the reality of the cosmos. The truth is that you are moving. You are moving at speeds that would tear a machine apart, drifting through a void darker and deeper than any ocean, spinning and spiraling in a complex ballet that has been performing without a pause for 4.5 billion years. The first layer of this motion is the one most intimate to us, the one that defines the rhythm of our lives, yet the one we so easily forget. It is the spin. At this very moment, the solid ground you rest upon is rotating. We are passengers on a massive sphere of rock and iron that is turning on its axis, pirouetting in the emptiness of space. To understand the scale of this motion, we have to look at the numbers, not as mathematical abstractions, but as physical realities. The Earth is vast. To travel around its equator is a journey of 40,000 kilometers. Yet, the planet completes this entire rotation in just under 24 hours. If you were standing on the equator right now, perhaps on a beach in Kenya or a boat drifting on the Amazon River, you would be traveling eastward at a speed of roughly 1,670 kilometers per hour. It is a staggering velocity. It is faster than the speed of sound. It is faster than a commercial jetliner cruising at high altitude. While you sleep, while you breathe, you are hurtling sideways at supersonic speeds. The reason you do not feel this rush of wind, the reason you are not thrown backward against the wall, is because everything around you is moving at exactly the same speed. The atmosphere is not a static casing through which the Earth spins. It is a blanket that travels with us. The air in your room, the clouds floating lazily in the sky, and the birds gliding on the breeze are all carried along by the planet's momentum. It is like being inside the cabin of a high-speed train, moving over a perfectly smooth track. If you close your eyes on that train, you might feel stationary, even though the landscape outside is blurring by. On Earth, the track is smoother than any steel rail. It is the friction-free vacuum of space. This rotation is not uniform across the planet. It creates a subtle gradient of speed depending on where you are. If you are at the equator, you are moving at that maximum velocity, tracing the widest possible circle. But as you move north or south, the circle you travel in a day gets smaller. Someone sitting in a cafe in Paris or Vancouver is moving significantly slower than someone in Singapore, roughly 1,000 kilometers per hour. And if you were to stand at the very North Pole, you would not be traveling east at all. You would simply be turning slowly on the spot, completing one full pivot every 24 hours like a phonograph record player's center. This difference in speed is not just a curiosity, it shapes the physical world. The Earth is not a rigid solid, but a slightly elastic body, and the violence of its spin has consequences. Over billions of years, this rotation has flattened the planet slightly. We are not a perfect sphere. The centrifugal force, the outward push of the spin, causes the equator to bulge outward. The Earth is wider around the middle than it is from top to bottom. If you were to weigh yourself at the equator, you would weigh slightly less than you do at the poles, partly because you are farther from the center of the Earth's gravity, but also because the spin of the planet is trying, very gently, to throw you off into space. We do not feel the spin directly, but we can see it if we possess the patience to watch. The most obvious evidence is the sky. When we watch the sun sink below the western horizon, painting the clouds in shades of violet and gold, we say the sun is setting, but the sun is doing no such thing. The sun is a steady, burning anchor. It is we who are tipping backward. The horizon is rising up to cover the star. We are rolling away from the light. The night sky offers an even clearer view of this carousel. If you were to set up a camera on a tripod on a clear, dark night and leave the shutter open for hours, you would capture the truth. The stars, which seem so fixed to the naked eye, would streak across the image in long, curved trails. In the northern hemisphere, they appear to circle a single point, the North Star Polaris. This star sits almost directly above our axis of rotation. It is the hub of the wheel. The concentric circles of starlight in a long exposure photograph are not a record of the stars moving. They are a record of our own turning. We are the ones in motion, looking out at a universe that is merely waiting for us to pass by. This constant turning is the engine of our climate and our weather. It does not just carry us through the dark, it bends the wind. Because the equator spins faster than the poles, air moving north or south gets deflected. This is the Coriolis effect, a ghostly force that exists only because of our rotation. It is the reason hurricanes spin counterclockwise in the north and clockwise in the south. It is the invisible hand that twists the great storms and shapes the trade winds that guided ancient sailors across the oceans. Without the spin, our weather would be vastly different, likely far simpler and less dynamic. The complex, swirling patterns of clouds we see in satellite images are the visual signature of a planet in rapid rotation. What is truly remarkable is the consistency of this motion. The Earth is a heavy, massive gyroscope. Once set in motion, it wants to stay in motion. The momentum stored in the spinning rock of our planet is almost incomprehensible. It has been spinning like this since the violent collision that formed the Moon billions of years ago. There are subtle changes, of course. The Moon's gravity tugs at our oceans, creating tides, and the friction of that water sloshing against the continents acts as a very weak brake. The Earth's rotation is slowing down, but at a rate so imperceptible, milliseconds over centuries, that for all human intent and purpose, it is an eternal constant. There was a time when this concept was terrifying to the human mind. When astronomers first suggested that the Earth moved, it contradicted the common sense of gravity. If the Earth is spinning, why don't we fly off? Why doesn't the water in the ocean spill out? It took the genius of physics to explain that gravity holds us tight, and that we share the momentum of the source. We are part of the Earth system. When you jump in the air, you do not land in a different spot because the Earth moved beneath you. You land in the same spot because you too are moving at 1,600 kilometers per hour, even while you are in the air. Imagine the view from space looking down at this spinning blue marble. From a distance, the violence of the speed vanishes. You would not see a blur. You would see a majestic slow-motion revolution. You would see the line between day and night, the Terminator, creeping across the continents. You would see the lights of Europe waking up as the lights of America turn on. It would look peaceful, a silent drift, but that silence disguises the tremendous energy involved. The kinetic energy of the Earth's rotation is vast, a reservoir of power that keeps the atmosphere dynamic and the ocean circulating. This daily rotation is the first step in understanding our true place in the galaxy. It breaks the psychological anchor of here. Here is not a fixed point. Here is a coordinate that is constantly sweeping eastward, chasing the sunrise. Every morning when you wake up, you are, physically speaking, in a different position in space than you were when you went to sleep. The bed has traveled tens of thousands of kilometers in a great arc, but the spin is only a local motion. It is a rotation around a central spine. If this were the only way Earth moved, we would be a lonely top spinning in the dark, forever facing the same distant stars, forever locked in one place. But we are not. The axis itself is moving. The entire planet is drifting. The feeling of stillness is a multi-layered illusion. Just as the passenger on a train might walk down the aisle, moving relative to the train, while the train moves relative to the ground, Earth spins while it travels a much longer, much faster path. Let us return to the room where you sit. The air is still. The silence is heavy. But now, perhaps, you can sense the underlying vibration of reality. You can imagine the walls of your room cutting through the fabric of space. You can visualize the horizon dipping down, revealing new stars, hiding old ones. You are riding on the back of a giant, ancient creature of rock and magma that refuses to stand still. It is worth pausing to appreciate the stability of this ride. Despite the supersonic speeds, despite the complex physics of centrifugal force and gravity, the experience of life on Earth is gentle. The rotation does not rattle the teacups on the shelf. It does not spill the water in the lake. It is a motion so perfectly balanced, so smoothed by the sheer scale of the planet, that biology has never needed to adapt to the sensation of movement, only to the cycle of light and dark that it produces. We evolved in this centrifuge, and we are perfectly tuned to its frequency. This rotation is our heartbeat. It regulates the temperature of the planet, ensuring that no side is baked perpetually by the sun or frozen forever in the dark. It drives the photosynthesis of plants, the sleep cycles of animals, and the tides of the sea. It is the fundamental clock of existence. As we prepare to look further outward, to the motions that carry us out of our local neighborhood, remember this sensation of the spin. It is the baseline. It is the hum of the planetary engine. Even when we talk about galactic years and cosmic flows, this daily pirouette continues, relentless and steady. We are spinning tops, drifting in the great dark ocean. The illusion of stillness is comforting. It allows us to build houses and stack stones and pour water into glasses without fear. But it is a small truth. The greater truth is one of dynamic, unending energy. We are travelers. We have always been travelers. And the journey is about to get much faster and much more complex as we lift our eyes from the ground and look toward the burning star that holds us on a leash. The spin is just the beginning. The spin is just the warming up of the orchestra before the true symphony of motion begins. When we think of the Earth spinning, We often imagine it vertical, like a tabletop globe. But even here, there is a twist, literally. We are not spinning upright. We are tipped over. The axis of our rotation is tilted at 23.5 degrees relative to the path we travel. This tilt is the memory of a violent past, likely a collision with a Mars-sized object when the Earth was young and molten. That impact knocked us off balance, and we have stayed that way ever since. This tilt means that our spin is not just a simple rotation, it is a nodding motion relative to the sun. It is the reason the days grow long in summer and short in winter. It is the reason the sun climbs high in the sky in July and stays low near the horizon in December. We are a spinning top that is leaning over, presenting first our northern hemisphere, then our southern hemisphere, to the warmth of the star. So, as you lie there in the quiet, picture the geometry of your position. You are pinned by gravity to the surface of a sphere. That sphere is tilted. It is spinning at 1,600 kilometers per hour. You are rushing toward the dawn line, that eternal sunrise that sweeps around the globe. You are chasing the day. The stillness is a mask. Behind it lies the energy of a planet that has never known rest. This is the first secret of our movement. We are not static observers of the universe. We are active participants in a high-speed rotation. We are whirling dervishes on a cosmic stage. But as fast as this spin seems, as overwhelming as the supersonic speed of the equator might appear to our terrestrial minds, it is merely a crawl compared to the velocities that await us as we zoom out. The Earth does not just spin in place, it runs. It runs in a massive elliptical track, dragging us along with it. The walls of your room are not just rotating, they are translating. They are plowing through the vacuum. To understand where we are going, we must leave the comfort of the spin and look at the path ahead. We must look at the sun, not as a lantern in the sky, but as a gravitational master that is pulling us through the dark at speeds that defy comprehension. The day is defined by the spin, but the year is defined by the journey. And that journey is far more intricate than a simple circle. We have felt the spin, that silent daily rotation that turns night into day. But if we could detach ourselves from the Earth, float up through the clouds, and watch from a great distance, the spin would soon become a minor detail. From high above the plane of the solar system, looking down at the sun, the Earth would appear as a small blue dot, and its most defining motion would not be its rotation, but its frantic rush around the star. This is the second layer of our journey, the orbit. While the Earth spins at a leisurely 1,600 kilometers per hour at the equator, it travels through space at a breathtaking 107,000 kilometers per hour. To visualize this speed, imagine a rifle bullet. It is one of the fastest things humans have ever engineered for everyday use. The Earth moves nearly 30 times faster than a speeding bullet. In the time it takes you to read this sentence, you have traveled hundreds of kilometers through space. In the time it takes to watch a movie, you have traveled a distance equal to the width of a continent. We are racing around the sun. It is a journey of nearly 1 billion kilometers every single year. We do not feel this speed for the same reason we do not feel the spin. The motion is incredibly smooth. There are no bumps in the vacuum of space, no friction to slow us down, no air resistance to roar in our ears. We are in a state of perpetual freefall, falling around the sun, held in place by the invisible tether of gravity. Most of us were taught in school that the Earth orbits the sun in a circle. We imagine a flat dinner plate arrangement with the sun sitting still in the middle and the planets rolling around the rim like marbles. This image is simple, elegant, and almost entirely wrong. The reality is far more dynamic. The sun is not a stationary anchor, it is a traveler itself. The sun is a star, one of hundreds of billions in the Milky Way galaxy, and like every other star, it is in motion. It is orbiting the center of the galaxy at a phenomenal speed of roughly 800,000 kilometers per hour. It is dragging the entire solar system, Earth, Mars, Jupiter, and all the rest, along with it. This changes the shape of our path completely. We are not tracing a closed circle in space. We are never in the same place twice. If you could trace the Earth's movement through the galaxy, it would not look like a ring. It would look like a helix. It would look like a corkscrew spring stretched out through the darkness. Imagine a car driving down a long, straight highway at night. Now imagine a fly buzzing in circles around the car's headlights. To the fly, it is just circling the light. But to someone standing by the side of the road, the fly is tracing a spiraling coil through the air, moving forward as it loops around. We are that fly. The sun is the car, speeding through the galactic arm. Every year when we complete one orbit, we do not return to where we started. We are billions of kilometers away from that spot. We have advanced along the galactic track. The concept of a year is a measurement of relative position to the sun, not a return to a fixed point in the universe. In the grand geography of the cosmos, we are constantly exploring new territory. The space we occupy right now, at this very second, is space that Earth has never touched before and will never touch again. This helical motion is wild and beautiful. The sun leads the way, plowing through the interstellar medium, and the planets trail after it, spinning around its wake. Because the plane of our solar system is tilted at about a 60-degree angle relative to the direction of the sun's motion through the galaxy, we aren't just trailing behind. We are swooping ahead and looping back. For half of the year, the Earth is technically moving faster than the sun, overtaking it on the inside track of the galactic curve. For the other half, we are looping back around, moving slightly slower than the sun relative to the galactic center, allowing the star to catch up. We are dancing a complex tango, weaving in and out of the sun's path, spiraling endlessly forward. This creates a spectacular image in the mind's eye. We are not sitting on a flat disk. We are part of a vortex, a dynamic, rushing tube of planetary motion, boring a tunnel through the void. The seemingly stable arrangement of the night sky is actually a convoy of worlds hurtling into the unknown. But let us zoom back in for a moment to the mechanics of this yearly loop. The orbit itself, the shape we trace around the sun, is not a perfect circle. It is an ellipse, an oval. This means that our distance from the sun changes throughout the year. We have a closest point, called perihelion, which occurs in early January, and a farthest point, aphelion, in early July. It seems counterintuitive to those in the northern hemisphere that we are closest to the fire of the sun in the dead of winter. But this difference in distance, about 5 million kilometers, is not enough to dictate the seasons. The seasons are ruled by that tilt we discussed earlier. However, this changing distance does affect the speed of our travel. Kepler's laws of planetary motion tell us that a planet moves faster when it is closer to its star. So, right now, as we navigate the months of January and February, the Earth is accelerating. We are at our top speed, whipping around the sharp end of the ellipse. By July, we will be sluggish, hanging at the top of the curve, moving more slowly before gravity pulls us back in. This subtle change in speed means that the northern summer is actually a few days longer than the northern winter. The Earth lingers in the summer months, taking its time, and rushes through the winter. This variation in speed is another layer of complexity. We are spinning, we are spiraling, and as we spiral, we are pulsing, speeding up and slowing down with the rhythm of a breathing lung. The path we take is not entirely ours to choose. We are not alone in this system. We share the solar track with giants. Jupiter, the massive gas planet, is so heavy that it pulls on the Earth. Venus, our nearest neighbor, tugs at us too. These gravitational whispers mean that our smooth ellipse is actually slightly jagged. Over thousands of years, the shape of our orbit stretches and circularizes. It breathes. These cycles, known as Milankovitch cycles, change the climate of our world over eons. They are the pacemakers of the ice ages. A slight stretch in the orbit, a slight wobble in the spin, and the Earth can plunge into a 10,000-year freeze or warm into a tropical greenhouse. The motion of the Earth is the history of life. We are at the mercy of these celestial mechanics. Let us return to the corkscrew. The helical model of the solar system became popular on the internet a few years ago, often accompanied by animation showing the sun shooting forward like a comet and the planets swirling behind it in a chaotic vortex. While the spirit of those animations captured the forward motion, they often exaggerated the chaos. The truth is more dignified. The entire solar system is flat like a frisbee. This frisbee is flying through the galaxy at an angle. So, the planets are orbiting in the same plane, but that plane is moving forward. It is disciplined. It is ordered. Gravity is a strict conductor. The planets do not lag behind or get left in the dust. They are bound tight. The speed of gravity, which is the speed of light, ensures that the sun's grip is instantaneous and firm. We are locked in this formation, a synchronized swimming team diving into the deep end of the galaxy. Consider the environment we are moving through. We often think of space as empty, a perfect vacuum. But as the Earth spirals along this path, it is plowing through a very thin soup of particles. The solar wind, a stream of charged particles erupting from the sun, creates a bubble around us called the heliosphere. We live inside this bubble. As the sun moves through the galaxy, it pushes against the interstellar medium, the gas and dust that floats between the stars. This creates a bow shock, like the wave in front of a ship. The Earth, in its spiral, spends its time safely tucked inside the sun's protective magnetic sphere. We are being shielded from the harsh radiation of deep space by the very star that drags us on this journey. We are in a traveling cocoon. Sometimes, the Earth's path takes it through denser patches of cosmic dust. These are the meteor showers we see. When we look up in August and see the Perseids streaking across the sky, we are witnessing the Earth slamming into the debris trail of an ancient comet. We are driving through a cloud of gravel at 100,000 kilometers per hour. The shooting stars are the windshield splatter of our cosmic drive. This spiraling journey creates a profound sense of time. If you think of the eye, Earth's path as a thread, we are weaving a tapestry that stretches back 4.5 billion years. The thread is incredibly long. Since the formation of the Earth, we have spiraled around the galaxy roughly 20 times. Each spiral is a different era. In one loop, the Earth was molten. In another, it was covered in ice. In another, dinosaurs walked the supercontinents. Now, In this current loop, we are here, looking up, trying to understand the ride. It is a lonely path in some ways. The distances are vast. Even though we are moving at these immense speeds, the stars around us appear fixed. This is because they are also moving, often in similar currents, but mostly because they are so unimaginably far away. We are like ships on a distant horizon. Even if we are both speeding, the gap between us changes slowly. But it does change. If we could watch for 1,000,000 years, we would see the constellations distort and break. The Big Dipper would bend, Orion would lose his belt. We are moving through a dynamic star field. The fixed stars are travelers too, each on their own spiral path, each obeying the gravity of the galactic core. So, the second illusion to break is the circle. We are not going in circles, we are going forward. We are on a linear trajectory that is bent by gravity into a loop, but the net result is progress into the void. This helical path has implications for how we view the universe. When we look out at the galaxy, we are looking from a moving platform. Astronomers have to account for this. When they measure the light from a distant star, they have to subtract the Earth's speed, the Sun's speed, the orbital wobble and the spin. They have to mathematically freeze the frame to understand what they are seeing. There is a beauty in this complexity. It means that the Earth is not a cage, it is a vessel. We are currently navigating a quiet sector of the galaxy, a place between the major spiral arms, a suburb of the Milky Way. But we are moving toward other regions. The view will change. The sky of our distant descendants will be different from ours. The sun is pulling us toward the constellation Hercules. That is the direction of our solar apex, the point we are aiming for. We are flying toward the bright star Vega. We won't get close to it for millions of years, and by the time we get there, Vega will have moved on. It is a perpetual chase. As you rest, let this image settle in your mind. You are spinning, and while you spin, you are spiraling. You are carving a helix through the dark. The bed you lie on is a vehicle. The room you inhabit is a cabin on a ship. The speed is tremendous, but the ride is smooth. We have left the stillness of the ground. We have left the simple circle of the year. Now we must look at where this spiral is actually taking us. We are not just moving through empty space, we are moving through a landscape. The galaxy has geography. There are clouds, there are bubbles, there are streams of invisible matter. We are about to enter the local neighborhood. We are about to look at the weather of the galaxy. The Earth is currently passing through a very specific, very strange cloud of gas. It is a fog bank in the interstellar night. This is the next stage of our understanding. We are not just moving, we are interacting. We are sailing through the mist. We have established that the Earth is spinning like a top and spiraling like a moth around a flame. We understand the geometry of our motion, but now we must ask a different question, one that concerns the texture of the space itself. When a ship sails across the ocean, it does not just move through a geometric coordinate system, it moves through water. It encounters choppy seas, calm patches, currents of warm water, and banks of cold fog. The galaxy is no different. We are not traveling through a true void. We are currently on a voyage through the local interstellar cloud. To understand this, we must first dismantle the idea of empty space. When we look up at the night sky between the stars, it looks pitch black and completely vacant. We are taught that space is a vacuum, and in many ways, it is. It is emptier than any vacuum chamber humanity has ever built on Earth. But it is not nothing. The space between the stars, the interstellar medium, is filled with gas, dust, cosmic rays, and magnetic fields. It is a landscape. It is a terrain of tenuous matter that stretches for light years. And just like the weather on Earth, the weather in the galaxy changes depending on where you are. For the last 60,000 years or so, a span of time that covers the entire history of modern civilization, from the first cave paintings to the digital age, our solar system has been drifting through a specific wispy patch of galactic fog. Astronomers call this the local interstellar cloud, or sometimes, more affectionately, the local fluff. Imagine a cloud in the sky on a summer day. It looks solid from a distance, white and fluffy with defined edges. But if you were to fly an airplane through it, the transition would be subtle. You would simply find yourself in a mist. The local interstellar cloud is similar, but on a scale that defies terrestrial logic. It spans roughly 30 light years across. It is a staggering distance. If you could travel at the speed of light, it would still take you 3 decades to cross from one side of this mist bank to the other. The Earth, trailing behind the Sun, is deep inside this structure. We are mariners in the middle of a fog bank that is so thin we cannot even see it with our naked eyes. The density of this cloud is incredibly low. On Earth, at sea level, a cubic centimeter of air contains billions upon billions of molecules. In the local interstellar cloud, a cubic centimeter contains, on average, roughly 1 atom. It is a ghost of a cloud. If you were floating inside it, outside of a spaceship, you would not see a haze around you. The stars would still shine brightly. Yet, to the sensitive instruments of astronomers and to the physics of the galaxy, this cloud is a tangible thing. It is material, it has mass, and as our solar system plows through it at supersonic speeds, we interact with it. We are not exposed to this cloud directly. We are protected by a shield. The sun is more than just a source of light and gravity. It is a source of pressure. It constantly exhales a stream of charged particles known as the solar wind. This wind blows outward in all directions, past Mercury, past Earth, past the gas giants, and even past Pluto. It creates a gigantic bubble around the solar system called the heliosphere. Think of the heliosphere as a magnetic cocoon. It is the hull of our ship. As the sun moves through the local interstellar cloud, the solar wind pushes the cloud's material away, creating a cavity in the mist. We live inside this cavity. We are traveling in a dry, safe bubble through a damp galactic environment. The boundary where the solar wind meets the interstellar cloud is a violent and fascinating place. It is called the heliopause. It is the edge of the sun's influence. Only recently, in the span of human history, have we physically touched this edge. The Voyager spacecrafts, launched in the late 1970s, traveled for decades to reach it. When Voyager 1 finally crossed that threshold and entered the interstellar medium, it detected a change. The sound of space changed. The density of the plasma outside was higher than inside. It was cooler, denser, and filled with the debris of other stars. Voyager had left the harbor and entered the open ocean. So, what is this cloud made of? It is a mixture of hydrogen and helium, the primordial elements of the universe, seasoned with a dusting of heavier elements. It is warm, sitting at a temperature roughly equal to the surface of the sun. Yet because the atoms are so spread out, it holds no heat that a human would feel. It is a paradoxical environment, hot in terms of atomic energy, but freezing in terms of density. The origin of this cloud tells a story of violence and rebirth. The galaxy is a recycler. Stars are born, They live and they die. When massive stars die, they explode as supernovae, blasting their material out into the void. This material, the ash of the dead star, drifts through space, cooling and clumping together. The local interstellar cloud is likely the remnant of a violent event that happened millions of years ago. We are drifting through the exhaust plume of a long-forgotten stellar catastrophe. But the context gets even larger. This cloud is not floating in a crowded room. It is floating in a clearing. The local interstellar cloud sits inside a much larger structure known as the local bubble. This bubble is a colossal cavern in the arm of the Milky Way, stretching hundreds of light years across. It is shaped like an hourglass or a peanut. It is a region where the gas density is significantly lower than the galactic average. Astronomers believe that 10 or 20 million years ago, a cluster of massive stars in our neighborhood reached the end of their lives. They exploded one after another like a chain of firecrackers. The force of these supernovas blew the gas of the galaxy away, carving out this massive hollow. It cleared the chimney. It pushed the heavy dust and gas into a shell around the edges, leaving the interior, our current location, relatively empty. Our sun did not form in this bubble. We drifted into it. In our long spiral around the galaxy, we wandered into this clearing about 5 to 10 million years ago. And now, within this clearing, we have encountered a solitary wisp of gas, the local interstellar cloud, drifting through the void. It creates a beautiful image of our current situation. We are a tiny solar system wrapped in a magnetic bubble drifting through a wispy cloud, which is itself floating inside a massive cavern blown out by dead stars. We are nesting dolls of cosmic geography. This journey through the cloud is temporary. In the vast timescales of the universe, it is a brief encounter. We are moving toward the edge of the local interstellar cloud. Calculations suggest that within the next 10,000 to 50,000 years, a blink of an eye in geological time, we will exit this fog bank. What happens then? We will enter the next region of the local bubble. We might encounter another cloud, perhaps the G cloud that sits adjacent to ours, or we might enter a region of even clearer space where the density drops to near zero. This transition is not just a matter of scenery. The density of the interstellar medium affects the Earth. When the solar system passes through a denser cloud, the heliosphere, our protective bubble, can shrink. If the pressure from the outside is strong enough, it pushes the walls in. If we were to encounter a truly dense cloud, the heliosphere could be pushed back inside the orbit of Saturn or even Earth. In that scenario, the interstellar gas and the cosmic rays it carries would rain down directly onto our atmosphere. Some scientists speculate that Earth's past ice ages or extinction events might be linked to these galactic crossings. If we passed through a dense nebula in the distant past, the influx of cosmic dust could have altered our climate, seeding clouds or stripping away ozone. We are not isolated from the galaxy. We are intimately connected to the ground we drive over. But for now, the passage is smooth. The local interstellar cloud is tenuous and gentle. It exerts a pressure, but the sun is strong. The heliosphere holds firm, out past the orbit of Pluto, keeping the interstellar weather at bay. As you lie there, imagine the view from the bow of the ship. The sun is the prow, cutting the waves. The bow shock is invisible to us, but it is there, a standing wave of plasma glowing faintly in the ultraviolet, marking the boundary where our home ends and the alien ocean begins. We are surfing the galactic wave. This motion through the cloud adds a texture to our speed. We are not just moving fast. We are moving against something. There is a wind in our face. It is a wind of hydrogen atoms striking the magnetic shield of the sun. It creates a tail behind us. Just as a comet has a tail, the heliosphere leaves a wake of disturbed plasma trailing behind the solar system as we corkscrew through the cloud. We are leaving a footprint in the mist. This local geography reminds us that the galaxy is not uniform. It is patchy. It is clumpy. It has structure. Just as a drive across a continent takes you through forests, deserts, wetlands, and mountains, our drive around the galaxy takes us through different environments. We happen to be in a fairly pleasant, quiet meadow at the moment, but we have driven through storms before, and we will drive through them again. The local bubble itself is surrounded by a wall of dense, star-forming gas. As the shock waves from those ancient explosions pushed the gas outward, they compressed it. On the surface of our bubble, new stars are being born today. We are sitting in the quiet eye of the storm, while the rim of our bubble is alive with the fires of creation. There is a comfort in knowing our address. We are not lost in an infinite featureless dark. We can pinpoint our location: Milky Way galaxy, Orion arm, local bubble, local interstellar cloud, solar system, Earth. We are somewhere specific, and this specific place has a feeling of age to it. The dust we are moving through is ancient. It is the recycled stardust of ancestors. The atoms currently bumping against the nose of the Voyager spacecraft might have once been part of a star that shone on a sky with no planets. Now, they are a gentle mist through which a world full of life is silently passing. The quietness of the night takes on a new depth when you realize this. The silence in your room is connected to the silence of the heliosphere, which is connected to the silence of the local cloud. It is layers of quiet, protecting us from the roar of the cosmic machinery. We are passing through. We are just passing through. The cloud was here before we arrived, and it will be here after we leave, slowly morphing and dissipating over millions of years. We are guests in this sector, and as we drift through this mist, the entire system, the bubble, the cloud, the sun, and the earth, is being carried along a much grander curve. We are not just drifting locally, we are orbiting globally. The cloud is moving, and we are moving with it, locked in the gravitational grip of the galaxy itself. The local weather is fascinating, but the climate is defined by the galactic year. We must now lift our eyes from the fog immediately outside our window and look at the horizon. We must look at the great wheel of the Milky Way. The spiral path we discussed earlier is just a small kink in a massive circular orbit that takes nearly 250 million years to complete. We are about to step onto the cosmic carousel. The scale of time and distance is about to expand from millions of years to hundreds of millions, from light years to kiloparsecs. The local cloud is just a speck of dust on the windshield of a vehicle traveling a path so long that complex life on Earth has not even existed for one full lap. We have traveled from the spin of our daily lives to the spiral of our yearly orbit, and through the misty corridors of the local interstellar cloud. But now, we must summon our powers of imagination to grasp a motion so grand, so slow, and so majestic that it dwarfs everything we have discussed so far. We must look at the galactic year. If you were to leave the solar system entirely and travel far above the disk of the Milky Way, looking down upon our home galaxy, you would see a structure of breathtaking beauty. You would see a glowing whirlpool of light, a pinwheel of stars roughly 100,000 light-years across. It is a spiral galaxy composed of twisting arms of blue and gold, wrapped around a dense, burning core of yellow-white light. Somewhere in the quiet suburbs of this city of stars, about 26,000 light-years from the center, sits our Sun. It is just one speck of light among hundreds of billions, and like every other star in this vast disk, it is moving. The entire galaxy is turning. It is a cosmic carousel of unimaginable proportions. The Sun, and the Earth along with it, is orbiting the center of the Milky Way. But this is not an orbit measured in months or years. The distances are so vast that a human lifetime is less than a blink of an eye. The speed at which we travel this circuit is ferocious, roughly 800,000 kilometers per hour. It is a velocity that would take us from New York to London in less than 30 seconds. Yet, the circle we must travel is so enormous that it takes approximately 230 million Earth years to complete just one single lap. Astronomers call this period a cosmic year, or a galactic year. It is a measure of time that breaks the human clock. To understand it, we cannot look at calendars or history books. We must look at the rocks beneath our feet and the fossils buried deep within the strata of the Earth. The history of our planet is written in the language of galactic years. Let us turn back the clock one single galactic year. If we rewind the tape of history by one full orbit, 230 million years ago, Earth was a completely different planet. We were not in this part of the galaxy. We were on the other side of the wheel. The stars in the sky were different. The constellations we know today did not exist. One galactic year ago, the dinosaurs were just beginning their reign. The massive continents we know today, Africa, the Americas, Europe, Asia, were smashed together into a single colossal supercontinent called Pangaea. The Atlantic Ocean did not exist. The flowers had not yet evolved. The birds were not yet in the sky. It was the Triassic period. The planet was hot, dry, and alien as the Earth moved through that previous orbit, slowly tracing its arc through the void. Pangaea broke apart. The continents drifted. The oceans opened. The Jurassic period came and went. The Cretaceous period flourished. The Tyrannosaurus rex rose to power and then vanished when the asteroid struck. The mammals emerged from their burrows. The ice ages came and thawed. The human species evolved, learned to make fire, built pyramids, sailed ships, and finally looked up at the stars. All of that, the entire rise and fall of the dinosaurs, the shifting of the continents, the entire history of mankind, happened in the span of one single lap around the galaxy. If we go back 2 galactic years, 460 million years ago, we find an Earth that is almost unrecognizable. There were no trees. The land was barren rock and moss. Life was almost entirely confined to the oceans. Primitive fish were swimming in the warm seas, and giant sea scorpions patrolled the reefs. The land was silent. If we go back further, the count becomes small. The Earth is roughly 4.5 billion years old. In galactic years, our planet is a young adult. We are roughly 20 galactic years old. The Sun has circled the Milky Way only 20 times since its birth. When the Sun was born on its first galactic orbit, it likely formed in a cluster with thousands of other siblings, lighting up the nebula that birthed them. By the second orbit, those siblings had drifted away, lost in the currents of the disk. By the 10th orbit, The Earth's atmosphere was filling with oxygen, rusting the oceans red. By the 18th orbit, the Cambrian explosion filled the seas with complex life. We are currently in the early months of our 21st galactic year. This perspective changes how we feel about deep time. It transforms the terrifying expanse of aeons into a manageable rhythm. The galaxy is a clock. The rotation of the spiral arms is the sweeping of the hour hand. But this journey around the galaxy is not just a smooth ride through empty space. The Milky Way has geography. It has structure. As we orbit, we do not stay in the same environment. We pass through the spiral arms. The spiral arms of the galaxy are not solid structures. They are not rigid spokes on a wheel. They are density waves. Imagine a traffic jam on a highway. The cars slow down, bunch together, and then speed up again as they leave the congestion. The traffic jam itself stays in one place, or moves slowly, while the cars rush through it. The spiral arms are cosmic traffic jams. They are regions where gravity has caused the gas and dust and stars to bunch up. As these clouds of gas compress, they ignite with new star formation. This is why the arms look blue and bright in photographs of other galaxies. They are lit by the fires of young, hot, massive stars. Our sun travels through these arms. It moves faster than the spiral structure itself. Over the course of a galactic year, we catch up to an arm, enter it, traverse it, and then leave it behind to cross the darker, quieter gaps between the arms. Currently, we are in a relatively quiet space. We are located in the Orion Spur, a minor bridge of stars and gas situated between two major spiral arms, the Perseus arm and the Sagittarius arm. We are in the countryside of the galaxy, a place of relative calm. This is fortunate for us. The spiral arms are dangerous places. They are crowded. The density of stars is higher. The amount of radiation is more intense. Because star formation is happening there, it also means that star death is happening there. Massive stars burn quickly and die violently as supernovae. To be inside a spiral arm is to be closer to these titanic explosions. Some scientists believe that Earth's mass extinction events might be linked to our passages through these major arms. Every time we plunge into a dense spiral arm, the risk of a nearby supernova increases. The risk of passing through dense molecular clouds increases. It is possible that the rhythm of life on Earth is synced to the rhythm of our passage through the galactic traffic jams. We enjoy the quiet interludes in the gaps where life can flourish undisturbed, and then we brave the crossing. But the crossing is slow. It takes millions of years to traverse an arm. It is not a sudden event, but a slow climatic shift in the galactic environment. What keeps us on this track? What is the anchor for this 200 million year orbit? It is the heart of the galaxy. 26,000 light years away, through the thick dust lanes of the Sagittarius constellation, lies the galactic center. If we could see it clearly, it would outshine the full moon. It is a region packed with old red stars, buzzing like bees around a hive, and in the very center of that hive lies a monster. Sagittarius AI is a supermassive black hole. It is an object with the mass of 4 million suns, crushed into a space smaller than the orbit of Mercury. It is the gravitational anchor of our galaxy. It is the hub of the wheel. We are falling toward it. Just as the Earth falls around the Sun falls around this black hole. But we are moving fast enough sideways that we never get any closer. We are in a stable, eternal dance with the dark heart of the Milky Way. There is something profoundly reassuring about this stability. The galaxy is not chaotic. It is ordered. It is a system that has maintained its structure for billions of years. The sun stays in its lane. The Earth stays with the sun. We are not drifting aimlessly. We are part of a grand, cohesive architecture. However, the view from Earth does change over these vast timescales. Because the stars closer to the center orbit faster than we do, and the stars further out orbit slower, the arrangement of the night sky is constantly churning. The constellations are temporary. If you could stand on Earth for a sizable fraction of a galactic year, you would see the sky flowing like a river. Stars would stream past us, overtaking us on the inside track, while we would overtake others on the outside. We are passing through a stream of stars right now. The bright stars of Orion, the Pleiades, the Sirius system. These are our current travel companions. They happen to be nearby at this moment in the lap. But in 10 million years, they will have drifted away, and new stars will take their place. The night sky is a windshield, and the stars are the scenery passing by. We can also look forward. Where will we be in the next galactic year? In 230 million years, the Earth will have completed another circuit. The continents of our planet will have merged again, perhaps forming a new Pangea. The Atlantic Ocean may have closed. The sun will be slightly brighter, older. Humans may be gone, or we may have spread to those passing stars. But the Earth will still be there. It will still be spinning. It will still be orbiting. It will be rounding the bend of the galaxy, sailing through the vacuum, faithful to the gravity that binds it. There is a concept in astronomy called the galactic habitable zone. Just as there is a zone around a star where the temperature is right for liquid water, there is a zone in the galaxy where conditions are right for life. If we were too close to the center, the radiation would be too intense and the gravitational tides too unstable. If we were too far out, at the edge of the disk, there would not be enough heavy elements, metals, carbon, oxygen, to build rocky planets like Earth. We are in the Goldilocks zone of the Milky Way. We are far enough from the dangerous core, but close enough to the rich, star-forming regions to have the materials we need. We are in the quiet suburbs, where the streets are wide and the hazards are few. Our location is not random. It is likely a prerequisite for our existence. The majesty of the galactic year lies in its scale. It reminds us that we are small, yes, but also that we are part of something incredibly old and incredibly enduring. The momentum of the sun carrying us around the galaxy is unstoppable. It is a journey that requires no fuel, no effort. It is a free ride on the curvature of space-time. As you visualize this, try to feel the curvature. The straight line of our motion is bending, ever so slightly, over thousands of years, curving around the distant center. We are banking the turn. The galaxy is a flat disk, and we are skimming across its surface like a skater on a vast frozen lake. But even this image of the flat disk is a simplification. The ride is not perfectly smooth. The road is not perfectly flat. As we circle the galaxy, we do not just stay in the plane. We drift up and down. We bob like a cork on the ocean. This vertical motion is the next layer of complexity. We have the spin, the spiral, the cloud, and the orbit. But now we must add the wave. We are oscillating. We are diving through the galactic plane and rising up the other side. This bobbing motion brings its own mysteries and its own dangers. It exposes us to different winds and different views. As we close the chapter on the great circle of the galactic year, we must prepare to examine the vertical journey. We are about to learn why the solar system is currently north of the galactic border, and what happens when we plunge back down into the thick of the disk. The carousel is not just spinning, it is undulating, and we are riding the wave. If we were to pause our journey now and look at the map we have drawn, the complexity would already be dizzying. We have felt the ground turning beneath us, watched the sun drag us in a corkscrew through the mist, and trace the immense, slow arc around the galactic core. But the universe has one more layer of geometry to reveal within our home galaxy, a motion that adds a gentle, rhythmic verticality to our travel. We are not just circling the center of the Milky Way, we are bobbing up and down. To visualize this, we must change our perspective of the galaxy. Instead of looking down on it from above, seeing the grand spiral face on, imagine moving to the side. Imagine viewing the Milky Way edge-on. From this vantage point, the galaxy transforms. It no longer looks like a whirlpool. It looks like a thin, glowing line of light suspended in the dark, with a bulging brightness in the center. It resembles a lens, or perhaps two fried eggs placed back to back. This flat disk is where the majority of the stars reside. It is the main street of the galaxy, but this street is not perfectly flat, and the stars within it do not travel in perfectly straight lines. As the sun orbits the center, it moves like a horse on a carousel, or a ship riding a gentle swell on the ocean. We drift up above the plane of the galaxy, cresting a wave, and then gravity pulls us back down. We plunge through the midline, sink to the depths below, and then rise again. This is the galactic oscillation. It is a slow, hypnotic breathing of the solar system. The physics behind this motion are elegant and simple. The galactic disk is dense. It is packed with gas clouds, dust, and billions of stars. This concentration of matter creates a strong gravitational pull. When a star like our Sun is sitting perfectly in the middle of the disk, the gravity pulling it up is balanced by the gravity pulling it down. But stars rarely stay perfectly centered. As soon as the Sun drifts slightly upward, away from the midline, the mass of the disk below it begins to pull it back. It acts like a giant, invisible spring. The Sun climbs higher and higher, slowing down as it fights against this gravity until it reaches its peak, the crest of the wave. Then it begins to fall. It accelerates back toward the disk, picking up speed. But when it reaches the middle, it does not stop. It has too much momentum. It plunges right through the crowded galactic plane and shoots out the bottom into the south of the galaxy. Now, the mass of the disk is above it, pulling it back up. The cycle repeats. Rise, fall, plunge, rise. This oscillation is much faster than the full orbit around the galaxy. While it takes 230 million years to complete a lap around the center, it takes only about 60 to 64 million years to complete one full bob up and down. This means that for every single orbit around the Milky Way, Earth dives through the galactic plane roughly 4 times. We are stitching a wave pattern through the fabric of the galaxy. Where are we right now in this cycle? We are currently rising. We are north of the galactic plane. If you define the plane by the equator of the Milky Way, the Sun is currently hovering about 55 light-years above the midline. In the grand scale of a galaxy that is thousands of light-years thick, this is a small distance. We are still considered to be in the disk, but we are definitely riding the upper currents. We crossed the exact middle of the galactic plane relatively recently, roughly 3 million years ago. This timing is fascinating. It means that when our earliest ancestors, the hominids appearing in the fossil record, were first beginning to walk upright on the plains of Africa, the night sky was filled with the dense, dusty star fields of the galactic midline. We have been climbing ever since, moving toward the cleaner, thinner air of the galactic heights. We will continue to rise for another 14 million years or so. At the top of our arc, we will be roughly 250 light years above the plane. From that height, the view will be spectacular. The dust that usually obscures the view of the galactic center will be below us. We will look down onto the starry carpet of the Milky Way. The band of the Milky Way that we see in our night sky today, that cloudy river of light, will appear brighter and more defined, stretching beneath our feet. Then, the slow fall will begin again. This bobbing motion is not just a ride, it is an exposure to different environments. The galaxy is stratified. The conditions in the middle of the plane are different from the conditions above and below. The midplane, the equator of the galaxy, is the busiest, most dangerous place to be. This is where the gravity is strongest. This is where the giant molecular clouds, the nebulas where stars are born, tend to congregate. When the solar system dives through this region, we are threading the needle through a crowded room. Passage through the galactic plane brings us closer to other stars. It brings us closer to the potential of encountering massive clouds of interstellar gas. Some scientists hypothesize that these crossings are hazardous for Earth. The theory is that as we move through the denser regions, the gravitational tug of nearby stars or gas clouds could disturb the Oort cloud, the vast shell of comets that surrounds our solar system. If the Oort cloud is jostled, it could send a rain of comets plunging inward toward the Sun, increasing the risk of impacts on Earth. It is a somber thought, suggesting that the mass extinctions of the past, the disappearance of the dinosaurs, the great dyings of the Permian, might be linked to the rhythm of this vertical wave. The Shiva hypothesis, as it is sometimes called, suggests that the galaxy itself acts as a clock of destruction and renewal. However, the evidence is still being debated. The timeline of extinctions does not perfectly match the timeline of our crossings, but the idea remains. Our vertical position matters. We are not disconnected from the geography of the disk. There is another aspect to this oscillation, shielding. The Milky Way has a magnetic field, and it also generates a wind of cosmic rays, high-energy particles zooming through space. When we are deep in the disk, we are somewhat protected from the harsh radiation of the wider universe outside the galaxy. The dust and gas of the disk act as a buffer. But as we rise up to the top of the wave, as we are doing now, we become more exposed. We are lifting our heads above the parapet. On the north face of the galaxy, there is less material to block the high-energy particles streaming in from intergalactic space. These extragalactic cosmic rays strike the Earth's atmosphere more frequently when we are high above the plane. This radiation is not necessarily lethal. Our own magnetic field and atmosphere do the heavy lifting of protecting life, but it changes the atmospheric chemistry. It may influence cloud formation. It may trigger subtle mutations in DNA, driving the slow engine of evolution. It is possible that the biodiversity of Earth is pushed forward by the moments when we peak above the galactic rim and expose ourselves to the winds of the deep cosmos. This wave motion gives the solar system a feeling of buoyancy. We are not grinding along a track, we are floating. The period of 60 million years is long, but it is a heartbeat in the life of the universe. It means that since the death of the dinosaurs 66 million years ago, we have completed almost exactly one full vertical oscillation. We have gone up, come down, gone through the bottom, and come back up to where we started. The dinosaur extinction event happened the last time we were in a similar position relative to the galactic plane, perhaps just as we were crossing through a dense region. Now we have come full circle. The cycle is complete. This vertical motion is gentle. The speed at which we rise is roughly 7 kilometers per second, compared to the 800,000 kilometers per hour of our orbit. This is a slow drift. It is a lazy rise. If you were watching the stars, you would not see them shifting up and down in a human lifetime. It is a geological motion, not a biological one, but it adds a beautiful complexity to the corkscrew model we discussed earlier. We are spiraling forward, yes, but that spiral is waving. The path of the Earth through the galaxy is not a simple spring coil. It is a slinky that has been bent and twisted. We are tracing a helical wave through the dark. Imagine a dolphin swimming alongside a ship. The dolphin moves forward with the ship, but it also leaps out of the water and dives back in. We are the dolphin. The galaxy is the water. We spend most of our time submerged in the stellar sea, but periodically we leap. We are currently in the middle of a leap. The calmness of this motion belies the immense forces at work. The restoring force, the gravity that pulls us back, is the combined mass of billions of stars. It is the collective hand of the galaxy keeping us close. We can never escape the disk. We can never fly off into the intergalactic void. We are tethered by gravity to the plane, destined to bob up and down forever, or at least until the sun dies. There is a comfort in this tether. It means we belong to the disk. We are creatures of the Milky Way's main sequence. We are not halo stars, those lonely wanderers that orbit in huge, erratic spheres far from the action. We are disk stars. We are part of the main population, the bustling metropolis of the galaxy. As we visualize this, let the feeling of the waves settle over you. You are on a planet that spins. That planet circles a star. That star spirals through space, and that spiral is bobbing up and down on a cosmic ocean. The motion is layered, like a complex harmony in a piece of music. The bass note is the orbit, the melody is the spin, the rhythm is the bobbing. The vastness of the timescales, 60 million years for a single breath of this cycle, should not make us feel insignificant. It should make us feel patient. The universe does not rush. It takes its time. It allows the Earth to rise slowly, giving life millions of years to adapt to the changing view, the changing radiation, the changing sky. We are currently enjoying a high point in the cycle. The view is clearing. We are moving toward the peak. We are rising out of the fog. But even this grand motion, this 200 million year orbit with its 60 million year wave, is not the final word. The galaxy itself is not a fixed island. The Milky Way is not hovering stationary in the universe. It, too, is falling. We must now zoom out to the final, most terrifying and most awe-inspiring scale of all. We must look at the river of galaxies. We must look at where the Milky Way is going, because we are being pulled by something so massive, so hidden, and so powerful that it defies easy description. We are spinning, spiraling, and bobbing, but we are also rushing at unimaginable speeds toward a gravitational anomaly, known only as the Great Attractor. The floor is about to drop out from under us one last time. We have reached the final frontier of our motion. We have peeled back the layers of the onion one by one. We started with the intimate spin of the Earth in your quiet room. We expanded to the spiraling orbit around the Sun, the drift through the local mist, and the majestic bobbing carousel of the Milky Way. Each step has increased the scale and increased the speed. But there is one last leap to make. It is a leap that takes us out of the galaxy entirely. The Milky Way is not an island universe floating alone in a static void. It is a member of a crowd. It is a droplet of light in a roaring river of galaxies, and this river is flowing fast. If you could step outside the Milky Way and hover in the deep intergalactic dark, you would see that our entire galaxy, the whole 100,000 light-year spiral, with its black hole heart and billions of stars, is rushing through space at a speed that makes all our previous numbers seem trivial. We are moving at approximately 600 kilometers per second. That is 2,160,000 kilometers per hour. At this speed, you could travel from Earth to the Moon in under 10 minutes. It is a velocity so extreme that it borders on the abstract. And yet, it is real. The entire stage on which our lives are played out, the Earth, the Sun, the local clouds, the spiral arms, is being dragged across the universe by an immense invisible hand. Where are we going? What could possibly be massive enough to pull an entire galaxy with such force? To answer this, we must look at our neighbors. The Milky Way belongs to a small family of galaxies known as the Local Group. Our most prominent sibling is the Andromeda Galaxy, a spiral even larger than our own, currently located about 2.5 million light-years away. For decades, astronomers have known that Andromeda and the Milky Way are falling toward each other. We are locked in a gravitational embrace, slowly closing the gap. In about 4 billion years, the two galaxies will meet and merge, forming a single, massive elliptical galaxy. It is a slow-motion dance of titans, a destiny written in gravity. But this local waltz is just a small eddy in a much larger current. The entire local group, us, Andromeda, and the dwarf galaxies buzzing around us, is being pulled toward a massive cluster of galaxies known as the Virgo cluster. The Virgo cluster is a city of galaxies. It contains over 1,000 individual galaxies, all swarming around a dense center. It is the downtown district of our local cosmic neighborhood. Its gravity is immense, and it is reeling us in. We are falling toward Virgo. But the story does not end there, because as astronomers mapped the skies, measuring the speeds and directions of thousands of galaxies, they noticed something strange. The Virgo cluster, and us along with it, and all the surrounding groups of galaxies are all rushing together toward an even larger, more distant point in the sky. We are all streaming toward a region in the constellation of Centaurus and Hydra. There, hidden behind the thick dust lanes of our own Milky Way, lies a gravitational anomaly of terrifying proportions. It is known as the Great Attractor. The Great Attractor is a mystery that has puzzled scientists for half a century. We cannot see it clearly because it sits in the zone of avoidance, the part of the sky blocked by the stars and dust of our own galactic disk. But we know it is there because we can see the effect it has on everything else. It acts like a giant drain in the bathtub of the universe. It is a concentration of mass equivalent to tens of thousands of galaxies. It is pulling on us, stretching across hundreds of millions of light years. The pull is gentle but relentless. It is a current that affects every atom in your body. We are drifting on a tide of gravity, flowing toward this mysterious accumulation of matter. This flow has allowed astronomers to redraw the map of the universe. We used to think of space as being divided into static clusters, but now we think of it in terms of watersheds. Imagine a landscape of hills and valleys on Earth. When it rains, the water flows down the hills, gathering into streams, then into rivers, and finally into a great ocean. Gravity organizes the water. The universe works the same way. The water is the galaxies. The basins are the gravitational wells. In 2014, a team of astronomers mapped these flows and realized that our Milky Way, the Virgo cluster, and the Great Attractor are all part of a single, colossal supercluster. They gave it a name that befits its grandeur, Laniakea. Laniakea is a Hawaiian word that means immeasurable heaven. It is a fitting title. This supercluster spans over 500 million light years. It contains 100,000 galaxies, and it is defined not by a hard wall, but by the flow. Every galaxy inside the boundary of Laniakea is flowing inward, toward the Great Attractor, just as every drop of rain in a watershed flows toward the same river valley. We are on the outskirts of Laniakea. We are a tiny speck of light near the edge of this gravitational basin, beginning our long drift toward the valley floor. We are part of a structure so vast that light itself takes 500 million years to cross it. We are not isolated. We are connected to 100,000 other islands of stars by the invisible threads of gravity. But even Laniakea is moving. The Great Attractor itself is being pulled toward an even larger structure, the Shapley supercluster, further out in the deep. It seems there is always a bigger fish. There's always a larger current. How do we know we are moving this fast? How can we possibly measure a speed of 600 kilometers per second when everything around us is also moving? We use the oldest light in the universe as our speedometer. The universe is filled with a faint background heat, the afterglow of the Big Bang, known as the cosmic microwave background. This radiation is everywhere, bathing the cosmos in a uniform temperature of 2.7 degrees above absolute zero. It should be perfectly even, but it isn't. When we look at this background light from Earth, we see a subtle distortion. The light coming from the direction of the constellation Leo, the direction we are heading, looks slightly warmer or bluer than it should be. The light coming from the opposite direction, behind us, looks slightly cooler or redder. This is the Doppler effect, the same phenomenon that makes an ambulance siren sound higher pitched as it drives toward you and lower pitched as it drives away. We are driving into the light of the Big Bang. We are plowing into the ancient photons, compressing them, shifting their color. This dipole in the cosmic background is the ultimate proof of our motion. It is the reference frame for the entire universe. By measuring this shift, we can calculate our absolute speed. We can say with certainty that the solar system is moving at roughly 370 kilometers per second relative to the universe itself. And when we add in the motion of the galaxy, we get the grand total velocity. So here we are. We have reached the sum of all motions. Let us stack them up one last time to feel the full weight of the journey. First, you are spinning on the axis of the Earth at 1,600 kilometers per hour, creating the rhythm of day and night. Second, you are orbiting the Sun at 107,000 kilometers per hour, spiraling through the seasons, creating the rhythm of the year. Third, You are drifting through the local interstellar cloud, surfing the bow shock of the sun, protected by the magnetic bubble of the heliosphere. Fourth, you are circling the center of the Milky Way at 800,000 kilometers per hour, bobbing up and down through the galactic plane in a rhythm of deep time that spans aeons. And fifth, you, the Earth, the Sun, and the entire Milky Way galaxy are rushing at 2 million kilometers per hour toward the Great Attractor, flowing down the gravitational rivers of the Laniakea supercluster. It is a symphony of speed, a hierarchy of motion. And yet, look around your room. Look at the shadows casting peacefully on the wall. Listen to the quiet of the night. The glass of water on your bedside table is calm. The surface is flat. It does not tremble. This is the miracle of inertia. This is the grace of physics. Despite these unimaginable velocities, despite the fact that you are hurtling through the cosmos faster than a rocket, you feel nothing. The ride is perfectly smooth. The universe carries you with a gentleness that contradicts its power. You are safe. You are anchored by gravity to this beautiful spinning rock. The atmosphere wraps you in a blanket of air that travels with you. You are not fighting this motion. You are part of it. You are not a passenger struggling to hold on. You are woven into the fabric of the journey. The feeling of stillness you experience right now is not a lie. It is a gift. It is the eye of the storm. The universe is a place of frantic energy, of burning stars and rushing galaxies, but here in this gravity well, in this quiet corner of the Orion Spur, there is peace. As you close your eyes, you can let go of the need to be still. You can surrender to the flow. You can visualize the great drift. Imagine yourself as a traveler on a ship that is sailing on a vast, star-filled ocean. The ship is large and steady. The currents are deep and strong. We are going somewhere. We are not just circling, we are evolving. The view is changing. The galaxy is turning. The great river of Laniakea is flowing, and we are flowing with it. There is no need to steer. There is no need to worry about the destination. The forces that guide us have been guiding the stars for 13 billion years. They know the way. So, as the Earth turns you away from the sun and toward the deep darkness of the infinite, remember that you are not falling into nothingness. You are flying. You are soaring through the greatest canyon of all, the canyon of space and time. The spin rocks you to sleep. The orbit cradles you. The galactic tide carries you. You are moving. You have always been moving, and you will keep moving safely, steadily, through the beautiful, silent night. Sleep well, traveler. The universe is driving.